Hi, welcome to SUSECON 2022. This is TUT 1051, Understanding Continuous Delivery in Rancher. In today's agenda, we're going to take a look at what continuous delivery is, sort of from an industry perspective. We're going to look at the architecture of how continuous delivery is integrated within Rancher. What are the advantages that Rancher brings? And then go check out the demo that follows that's associated with this session. I'm the speaker. My name is Brian. I'm a sales engineer with SUSE. I live here in Southern California. So if you're ever in the neighborhood, let's go catch a round of golf. So let's take a look at what continuous delivery is. Let's get to know it and understand it. In order to understand continuous delivery, we need to take a look at what it is a part of. So you'll notice that up here I've got this CI/CD definition. I usually spell things out, but you'll never see it spelled. You'll rarely see it spelled out. It's almost always CI/CD because there's just way too many letters. But CD is part of the CI/CD pipeline, and I say the word pipeline because in the graphic image you see here, you'll see this idea of a pipeline, and there's different pieces of the pipe. So those would be stages. And you'll notice there are arrows showing flow of information through the pipeline. So let's look at the definitions and maybe how they apply, excuse me, and how they apply, and maybe they'll all make a little better sense in the end. Continuous integration, and I'm going to have to read these. I couldn't find a better way to describe it without just reading it because it's really done well in these two particular examples. But continuous integration is a coding philosophy and a set of practices that all drive development of teams to frequently implement small code changes and check them into some kind of version control repository. And the teams that are building these applications need a consistent mechanism that will integrate and validate the changes that they've made. So this continuous integration should establish an automated way to code, build, package, and test their applications. And if they can get a consistent way of doing that, it will encourage them to do that even more. So continuous integration is all about the deployment, or not the deployment, but the development, the building and testing of source code, turning them into an application. Now, continuous delivery on the right-hand side picks up where continuous integration left off. It takes that built version of code and application and automates the deployment of that to whatever the respective environments are, whether it's production or test or dev. So it's an automated way to push that code change that's now been implemented into an application and deliver that or deploy that to whatever the target environment is. So as you can see from the pipeline, they would call it, how this would work from this graphical image example. And the arrows show starting from the left, a source stage, a source code stage, but then the iterative stages of building, testing, more testing, deploying to the different testing environments, and then into production. And then information about that deployment then flows all the way back. And that information could be errors that were learned along the way. They could also be comments or suggestions from end users and people who are testers all along the way, feeding back into modifying the source code to make that better. And then the process just continues and goes round and round. So the idea would be continuous integration and continuous delivery are all about building the applications and then deploying them to some target environment. There's also another piece that's also better to understand and that's GitOps. And in order to understand the continuous delivery within Rancher, it's good to know what GitOps is and what it leverages. So GitOps, as the definition here shows, is an operational framework that takes those best practices we sort of just talked about on the CI/CD side, and how those fit into a DevOps best practices approach. And instead of leveraging this whole version control and that collaboration as data leaves on the far right hand side and feeds back in, instead of leveraging that for just application code, use that for infrastructure automation. So the deployment of infrastructure code and changes in definitions, more of a declarative approach to how a system or infrastructure should look. Let's leverage some of those best practices that's worked so well on the application side and leverage that for the infrastructure. So you'll notice in our graphic image, I can have my infrastructure as code, so things that are dealing with the infrastructure, and also things that are dealing with config management or that application that we built using the CI/CD pipeline. And so by feeding that information into a Git repository, which is that version control sort of source or repository, but it gives you a place to define as the source of truth for all things related to your application or your infrastructure as code. And so the Git repo would be the source that would start the process of that pipeline that we saw on the previous slide. Feed that information into a continuous integration, continuous delivery pipeline, and then feeding that output, from an automation perspective, feeding that output to the appropriate target systems. And so the pipeline runs a series of tasks that then result in that update of the runtime environment, and that gets deployed out to whatever my target system. So I'm actually taking advantage of both the application delivery and infrastructure management and modifications all in one fell swoop. Now, the architecture from within Rancher looks like this. The continuous delivery component of Rancher is called Fleet. And so there is a fleet controller that is a component of your Rancher management cluster. And it sits in between the administrators that are making changes to the cluster and managing it. And it sits in between that GitOps repo where that information is stored. Remember, our source of truth, our applications, our infrastructure as code. All of that is stored here. Rancher's continuous delivery component, the cluster, the controller cluster, sits here in the middle, communicates with both of these, and manages the deployment to the downstream clusters. So if we were to step through this iteratively, we've got step one, where the administrator creates something called a cluster group. Now, that cluster group is defined by the administrator, stored on the Rancher management cluster, defining some kind of grouping of the clusters below. And it sets up for a very easy dynamic provisioning component, so that once I've established these cluster groups in the first place, as I build new clusters, by appropriately labeling those clusters to match the groupings that I've created, I can then get a full automated building of a cluster that assigns the appropriate labels, that then associates them with the appropriate cluster groups within continuous delivery, and therefore everything else flows. And we'll see what those things are. So the second step is also another administrative component, where the administrator defines where are those target or the source GitOps repos that we will be pulling information from to associate with those cluster groups that we've just defined. So the administrator defines the groups, defines the repos, associates those repos, which means whatever the applications or the infrastructure as code that they have within them, associate those with particular cluster groups. I can also do associations on a all cluster level. I can specify the existing cluster groups, or I can go and, from an advanced perspective, define a much more complicated way of mapping a particular repo to some target group of clusters. And then once that definition is done, Rancher then, in step 3, reads that repo that was defined in step 2, goes up to the GitOps repo, collects whatever is there, and creates what's called a bundle definition and stores that from within Rancher. Now, Rancher will poll that GitOps repo by default every 15 seconds, looking for new changes, any new commits that have been given. And when it finds something new or finds it for the very first time, again, it downloads, creates that bundle definition, but it also creates a hash that helps it understand what the different versions are and if changes are being made. And if you go in and visit the demo, I'll show you where that hash is exposed, so you can get kind of a better understanding of where it is. And then lastly, the clusters in step 4, the clusters pull those bundles from the Rancher management cluster, but they're then called bundle deployments from the downstream clusters perspective, pulls down those bundle deployments and deploys them to their clusters. Now, notice that those downstream clusters are not going to the Git repo. They are pulling all the information from Rancher. So Rancher is all that they need to know. They don't need to know where the Git repos are. And there could be many. There doesn't have to be just one. There could be many Git repos pointing to many different places with varied usernames and passwords and credentials needed to get there. Rancher knows all about that. Those downstream clusters don't need to know anything of it. So they'll download and do the deployments. They will reach out to Rancher management cluster for this, but they will also report back the state of that deployment. Was it successful? Was it a failure? And if it was a failure, what are sort of the details around that? You can get logging information and debugging information on that. Now, what are some of the advantages that Rancher brings by having continuous delivery integrated? Well, first off, it gives us a centralized roles-based access control system to leverage against these deployments. And this fits nicely with the notion of groupings with workspaces. So we talked about cluster groups a minute ago and how cluster groups can be created by the associated labels that are assigned to the different clusters that are out there, and creating a group from that. So it's very dynamic. But I can also do a separate kind of grouping called a workspace, and I can put clusters in different workspaces, and those workspaces can have their own roles-based access control. So I've got a centralized location for storing all of my users and their credentials, but I now have another level of roles-based access control assignment, because I can do so against workspaces. And those workspaces are then a grouping of all the different clusters that I have out there. So it gives me a way of doing sort of a decentralized administration approach to maybe application delivery to certain sets of clusters or configuration changes to clusters. But there's another thing that we've done, and that's the continuous delivery component, remember, called Fleet. When it looks in that repo that was defined, if it finds a fleet.yaml file, it says, oh, this is a very good thing. I can use this file to help customize the deployment of those, whatever I am finding as the source of truth. Those could be YAML files, YAML manifest files. They could be Helm charts or customized files. But I can grab that information, and before I deploy it, leverage this fleet.yaml file so that administrator can control different kinds of variables and substitutions of information as it's being deployed to the different clusters. So if the cluster it's being deployed to is a prod cluster, I want you to do it this way, and I want you to use these variables for information. If you're deploying to a cluster that's a dev cluster, then I want you to do it a little bit differently. And if it's a test cluster, I want it to be differently. And if it's a cluster in a certain environment, if it's on the edge, or if it's in the data center, if it's in the cloud, I want you to change and deploy it in a more customized approach. So this fleet.yaml, very powerful file, and very powerful way of controlling the application delivery and customizations to all the different environments. And, as this third bullet point says, it's conveniently integrated into Rancher. So from the same interface that I am registering and importing my clusters and managing their information, I'm also controlling the applications that they have. I'm controlling more of a Rancher in and of itself can do application deployment. But when I need to do deployments at scale, which is sort of the next bullet point over here, when I'm not just doing it onesie, twosie, when I need to do 5, 10, 100, or 1,000, or tens of thousands of servers, I don't want to leverage the one at a time approach. I need to leverage a more scalable approach, and that's the continuous delivery option within Rancher. So it's very scalable, and again, very convenient. That aspect, that at scale delivery mechanism is available in the same interface that you're doing everything else, roles-based access control and everything else. So there's more to come. We have a lot of things we're looking forward to doing. There's a lot of things that are in the pipeline to be delivered. So look forward to some of those new changes that are coming. So as I said, there is a demo that will be available. Go check out that demo. Go take a look at this in real time. And we look forward to seeing you at another SUSECON session.